Hello guys, Shekhar here. Are you tired of coding the same button again and again? Project after project? It's frustrating. And today we fixed that. We are building one smart button. Code it once, use it everywhere. It's super simple, conditional, and incredibly reusable. This won't be just a button. It will be your go-to button. It will save time for developers and save money for entrepreneurs. Plus, it's built to adapt easily to your future designs. Let's get started. First, let's create a new Flutter project. I am using IntelliJ, but feel free to use your preferred IDE or the terminal. We will name it the button project. When setting up, ensure Android, iOS and web are targeted. If you plan to build for additional platforms, you can select those options too. Then hit create. Once it's ready, you will see Flutter's default counter app code in the main .dart. This is a good sign. It means our project was set up correctly. We won't need the default counter app code, but let's leave it for now. Let's create our demo page, button demo page.dart. Inside this new file, we will create a stateful widget and name it button demo page. Why stateful? Because we will need to manage state later, like dynamically enabling or disabling our button. So stateful widget is the way to go here. And don't forget the essential material.dart import at the top. Now let's head into the build method, and we are going to replace Flutter's placeholder widget with a scaffold. Think of the scaffold as the main framework of your screen. It provides dedicated areas for key UI elements, the app bar and the body. We will focus on these two for now. Let's define our app bar first. We will give it a text widget for its title. How about our channel name? A little bit of self-branding never hurts, right? Next to the body. This is where the main action will be. For now, to make sure everything is wired up, just put a center widget holding some text saying, "Hello everyone." Alright, our button demo page is built. Now let's wire it up. To do that, head back to our main.dart file. By default, the material app points to my home page. We are going to change material app's home property to launch button demo page instead. Let's hit hot reload, and we should now see button demo page with our channel name, the Flutter dude in the app bar, and hello everyone message on the screen. That means everything's wired up correctly. It's time for some cleanup. We will delete the unnecessary classes and change the title of material app. Great. One last cleanup. Notice the debug banner in the top right? Let's hide that by setting the debug show checked mode banner property to false. Now let's create the action button. We will create a new file, ActionButton.dart. Inside it, we will create a stateless widget with the same name. In the constructor, we define three properties. First, onTap, which is a void callback that triggers when the button is tapped. Second is a label, a string for the text displayed on the button. And finally, a boolean is enabled, which defaults to true. It controls whether the button is active or disabled. Note that this is an optional parameter. Now diving into the build method, the first thing we do is grab the current theme data and color scheme. This is key for making our button adapt to the app's overall styling. To make the button state obvious to the user, we will define two different color sets. For the enabled set, we will use our app's primary theme colors, making the button bright with a clear border and easy to read text. For the disabled state, all those colors will become faded and transparent. This creates a standard grayed out look, which instantly tells the user the button is not interactive. Next, we will use an inkwell widget. This is great for detecting user taps and gives us those satisfying material design touch ripples. Inkwell's onTap is conditional. We only make the button clickable if its enabled is true. If not, it won't respond to taps. We also apply a border radius of 24 directly to the inkwell. This is important because it ensures the ink ripple effect is neatly clipped to the same rounded shape as our button's visual corners, which we define in the child container. The inkwell's child is a container widget, and this is where we really define the button's visual appearance. First, we apply some padding using edgeinsets.symmetric and give it a value 48 horizontally and 12 vertically. This gives our label plenty of breathing room and creates a generously sized button. For styling this container, we give it a box decoration. Here we set its color using our dynamic button background color variable, which changes based on whether the button is enabled. The border radius is also set to border radius.circular24. This not only gives us the nice rounded edges on the button itself, but also ensures its shape perfectly matches the inkwell's splash and highlight effects. And to complete the look, we add a border using border.all, applying our border color variable and setting the width to 1.5 to make it well defined. The container's child, a center widget, aligns its content to the middle, and the child of the center widget is of course our text widget. This is where we display the dynamic label string that's passed into our button. To style this text, we apply a text style. First, the color is set using our text color variable so that the text color will correctly update based on whether the button is enabled or disabled. Next, we set the font weight to fontweight.w500, which gives us a nice medium boldness that's easy to read. And lastly, the font size is set to 18, providing a clear and legible text size. Now that our action button is built, let's head back to our button demo page.dart to actually use it. Recall the demo page's center widget with hello everyone text. To add our button below, we will wrap center with a column for vertical arrangement. Once the center widget is the first child of the column, we can add our action button as the next child. When we add the action button, we will need to pass values for its properties. For the onTap property, let's provide a simple anonymous function that just prints a message to the console when the button is pressed, something like submit button tabbed. This will help us confirm it's working. And for the label property, let's pass the string submit. With those changes in place, let's go ahead and hit hot reload. We should now see our action button displayed on the demo page. After that last hot reload, you might notice a couple of things. Our button should be enabled by default and disabled by choice. Let's fix it quickly by changing is enabled to true in the optional parameter. And now let's focus on the layout issues. Everything looks a bit cramped up towards the top of the screen, and our action button is even stretching out to the entire width. That's not quite the polished look we are going for. No worries, we can easily fix this with some smart layout adjustments in our column. Let's update the code. First, for our main column widget, we will now set the main axis alignment property to main axis alignment dot space between. This is a really handy setting that tells the column to distribute any extra vertical space evenly between its children. Then we will remove the center widget that's wrapping our text. We don't need it anymore with this new layout. To make main axis alignment dot space between work effectively and to push our content around, we will introduce spacer widgets. So we will place one spacer at the very beginning of the column and another space between our hello everyone text and the row containing our button. These spacer widgets are super flexible. They expand to fill any available empty space. So they will push the hello everyone text down from the top and then push our button further down from the text. Next, we will wrap action button inside a row widget. We are doing this to control its horizontal sizing and alignment. By default, a row will shrink wrap its children. Then by setting main axis alignment to main axis alignment dot center on this row, our action button will be neatly centered on the children. And finally, at the very bottom of the column, we will add a sized box with a height of 24. This just ensures that there is always a little bit of clear spacing between our button, keeping it from hugging the bottom edge. Alright, let's hit hot reload and see it in action, in its final shape. Before moving forward, let's test that our button is working. We will tap on it and see the output on console. This will ensure that our button works as expected. Now let's test the disabled state. We will go ahead and pass false to is enabled property of our action button and then hot reload it. We should immediately see the difference. The button will now appear grayed out or more muted, visually indicating it's not currently interactive. Tapping it does nothing, no visual effect and no console print. The is enabled flag works perfectly. Okay, I have noticed the visual feedback on button press, the ripple effect, isn't very prominent. Let's address that. First, we will ensure the button is enabled so we can accurately see the on-pressed effect. When we press it, the ripple is hard to see. This happens because the inkwell ripple is confined too closely by the button's content and the edge of its colored background. So here is the fix. We will go into our button widgets code, and for the container that forms the button body, we will wrap its child with a new padding widget. We will give this new padding a small uniform value of 2. This padding adds space between the ripple background and the text, giving the ripple more area to animate distinctly. Now press the button and we will see that nice ripple effect much more clearly. It has the room it needs to animate and is now clearly noticeable on the button's surface. Now it's time to see our button in a real world use case. Often we need to perform some validation before enabling a button. A very common example is email validation. That's what we will implement. We are going to build a simple text field that validates an email address using a regular expression. No complex forms, just the essentials. To get started with the validation logic, we will need a few pieces in our widget state. First, we declare a text editing controller called email controller. This controller is essential. It will manage the text input for our email field, allowing us to access and control what the user types. Next, error text. This is a nullable string. It holds validation error messages for UI display. Then to define what a valid email looks like, we will set a regular expression called email reject. This variable holds a specific pattern designed to match the standard email format. It's our rule for checking the email structure. With these in place, let's look at the validate email function. This is the core of our validation logic. When this function is called, it first grabs the current text from email controller and uses trim to remove any accidental leading or trailing spaces. Then it checks if the cleaned email string has matched with our regular expression pattern. If the email does match, we call set state and set error text to null. This clears any previous error and set state updates the UI. However, if the email doesn't match, we again call set state, but this time we set error text to string invalid email format, which will then be shown to the user. Okay, with our validation logic ready, let's integrate this into our UI. On our demo page, we will replace the hello everyone text with our new email text field. Here is the text field widget itself. We assign our email controller to its controller property. The keyboard type is set to text input type.email address for users' convenience, bringing up the email-friendly keyboard. Inside input decoration, we set a label text of enter your email. Crucially, the error text property is linked directly to our error text variable, so any validation messages will appear right below the field. We also give it an outline input border for a clean defined look, and the onChanged callback triggers our validate email function. This means the email format is checked in real time every time the user types or changes the text. You will notice the text field is occupying the entire width and could be positioned a bit too centrally or high up for our liking. Let's quickly adjust its layout. We will wrap our text field in a sized box to give it a fixed width of say 350 pixels. And to add some spacing below it, we will add another sized box with a height of about 72 pixels right after it in our column. Now let's hit hot reload, and that's a much more balanced look. It's time to test the functionality. Let's try typing an invalid email. We should see the invalid email format error message appear. But it doesn't. There is something wrong. Let me put a print statement and check if the email is getting captured. And console output shows it does. Now I get it. We are missing the set state when our email is invalid. Let's wrap our error text in a set state and try it out. Now, let's type a correct email and the error message should disappear. Perfect. Our real-time email validation is working. Now for the crucial step. Let's connect this validation status to our action button. To manage the button's enabled state first, we will declare a new Boolean state variable in our widget. Let's call it isEnabled and initialize it to false. This means our button will start in a disabled state. Next, we need to update this isEnabled variable inside our validate email function, where we are calling the set state to update the error text. We will also update isEnabled. If the email format is valid, we will set isEnabled to true. Conversely, if the format is invalid, we will set it back to false. This way, isEnabled always reflects the current validity of the email input. Now that isEnabled is being updated correctly, the final step is simple. We just pass this isEnabled state variable to the isEnabled property of our action button. And that's it. The connection is made. Let's hit hot reload and see this complete flow in action. Notice the button starts disabled. Now, we will start typing in the email field. As long as the email is invalid, the button remains disabled. But the moment we type a valid email address, the error text vanishes and voila, our action button springs to life and becomes enabled. If we then edit the email to make it invalid again, the button correctly disables. Perfect. And there you have it. What started as a repetitive button setup has now transformed into a smart reusable action button. In this tutorial, we covered everything from basic setup and theme-aware styling to dynamic behavior like real-time email validation. This approach can easily be extended to other button types or components in your app. If you found this helpful, give it a like, subscribe for more Flutter tips and tutorials. Got questions or stuck somewhere? Drop them in comments, I read them all. Need help with your Flutter project? Feel free to reach out to me via email. I will do my best to help you out. Thanks for coding along, and I will see you in the next one. Bye-bye.